Okay, I guess it's time to get started. Thanks for joining our webinar today. We're working with a couple great partners, Microsoft and Red Hat, to present this content to you and share some of our real-world experiences and what we're seeing in the field and provide some tips and tricks on how you can leverage these technologies. So today we're going to talk about automated Azure builds with Ansible Tower, show you how you can leverage Ansible and Microsoft Azure to automate your infrastructure deployments and leverage some nice techniques that we've been leveraging with various customers. Presenters today are myself, Kyle Bassett, Aaron DeYoung, and Phil Thompson from Arctic. So let's get into it. So I'll go over today's agenda pretty quickly. So I'll introduce Ansible and what Ansible Tower is and some of the Azure integrations that are possible, the impact these technologies have on the business, common use cases, and we'll talk about some different modules. One of the big things we're going to talk about today is the concept of infrastructure as code. We'll dive into some of the basics and try to provide some of the benefits for you. Talk about some architecture, explain how Ansible Tower fits in and how it leverages Azure API services. We'll provide some demos and how you can take some of these use cases to the next level. Our plan is to post some of these techniques in a GitHub repo so you can do some self-learning after the fact. So look out for those links. You'll see them posted in a blog post along with some of the other material. We'll try to share some lessons learned and challenges you may face along the way. If we have time, we'll take a few questions and answers, but keep in mind you can always reach out to us if you want to dive into a deeper discussion via our website. So I'll cover one slide of what Arctic is. This slide really resonates since day one when we started Arctic, and it really depicts the top picture of, the old way of doing software development and trying to build this perfect product and maybe in 6 months finding out if you're going to be successful or not. What we like to do is deliver small, incremental, valuable offerings, and we really focus on the time to value, and that builds on the whole concept of continuous improvement. So every 2 weeks looking at that agile methodology or something in that ballpark. And also it's okay to fail sometimes, but fail fast and then, change your technique and move on to the next approach and keep iterating and keep delivering value for the business. So this is something we always try to focus on when we're starting new projects with customers. So let's dive into a brief history. I'm sure some of the people know the history of Ansible, but it was created by Michael DeHaan. He used to work in the CTO office at Red Hat and really focused on innovation and teamed up with a lot of great people in the community to bring this product to market. He really took a batteries included approach, and that was his motto. I really like that. And the idea was that if you were going to adopt the tool, you could immediately use it and drive value. We'll get into the module discussion and some of the things you can use later, but the idea wasn't like a programming language where you could just, have something yet invent everything. There's a way to kind of get started right away. So that was a really powerful part of the project and help people get off the ground. There's a few links here. We'll post these again later, but you probably want to check these out. One of the biggest moments, I think, for Ansible was when it was acquired by Red Hat in October in 2015. That really drove the community effort. Red Hat got really behind it. They kept it as a separate project and, it really drove the community side. And when you look at Galaxy, it's a way to share playbooks and share code and collaborate across the community. So I definitely recommend checking that out. Ansible Tower came later. It was a product that they were selling. That was the way they monetized Ansible before the Red Hat acquisition. And Red Hat, in true fashion of open sourcing all the products that they have and things they've acquired. So they did get to open sourcing that in September 2017, and that's called AWX. And you can freely download that. You can run it as a container in your OpenShift environment. You can run it in Microsoft Azure. It's part of the marketplace. I know they have a free trial, so you can certainly leverage that in some of your learning after of some of the enablement stuff we post. And we're obviously leveraging Azure. A lot of our customers, we see a great uptake on Azure. Customers are using it. They're moving their infrastructure. They're moving services into Azure. Interesting enough, it was codenamed Project Red Dog and launched way back in 2010. So it's been around a lot longer than most think. So one thing I like to focus on, I know my team's going to dive into some of the deeper technical aspects of Ansible and Ansible Tower and leveraging it with Azure, but what's the business value in all this? And I think something I like to talk about is automation is a business choice. It's not really a technology choice anymore. And every company is a technology company, and they need to embrace new technologies and change, or there's a lot of disruption in the market. You look at financial services and things like that. And there's new fintechs coming up, which is forcing some of these larger enterprise companies to be much more nimble and to maintain their market advantages. One thing it definitely does is when you move in this, it's hard to acquire talent in this area. And I think if you're using innovative tools and techniques, especially open source approaches, you're going to get that top talent. You're going to retain them because they want to be working on things. They want to be delivering business value, and they want to be iterating every day and accomplishing things. That leads into reducing technical debt. And when you start to drive everything from code, everything is versioned and is stored in a GitHub or a Git repo. Follow good practices where you're going to make code changes, do code approvals, do pull requests. So there's your documentation. There's your way to go back to last known good. So the days of complicated DR plans and rebuilding stuff by humans are going away. We have code repos, we build things, we rely on automation, we can trust it much more. So it allows us to recover and think of things differently and offer better services to our customers. Open source is a big piece of this. Obviously, everyone's adopted open source now. The community approach is working. We're able to share code. We're able to benefit from other people's techniques and ideas, and companies are much more willing to share that knowledge and that code and be able to benefit from this. So it's great to see open source alive and well, and public cloud providers adopting it. Obviously, Microsoft has a huge focus on open source, and if you look at the last 5 years or so, they've really upped their game in the open source space. So I mentioned obviously time to market advantages, being able to release code faster, fix bugs quicker, close security vulnerabilities faster is gonna help your business. And these things flow all the way through product and running services that you already run for a long time, but also releasing new services to get ahead of the market. So let's go quickly into what the tools do. So Ansible I describe as kind of the core automation tooling. So it's the part where you're going to start to write your playbooks and start to do your automation in. That's the best place to start. You don't need a full enterprise solution. Get some of your team members leveraging the tool. Get them learning and get them, doing small techniques to automate. Things even like patching. Configuration management has been a popular topic for a long time, and Ansible's certainly kind of won the race in that, if you ask me, and now they're rounding their portfolio out to do much more things. Tower really is the enterprise version, kind of I describe, of Ansible. Ansible Core is obviously underneath the covers, but Tower is going to give you those enterprise features that you're going to need. Things like privileged access, a user interface, reporting. One of the biggest things it's going to have is an API, so you can integrate it with other tools that you have. Maybe you have you want to front end things by ServiceNow or something like that, and you want to create a request process. So at the end of that approval, there's nothing stopping you from sending an API call to Tower, and Tower's got a full workflow built into it, so you can start to build workflows and automate all these aspects, and you're going to get a lot of reliability. Back to my comment around Git integration. Most people are taking the technique of the code is in Git and Tower's source of truth. So now you've got good documentation, you've got a good repo there. Templating is another big one we'll get into, is you can build templates. So you have reliability, you can start to provide self-service to people. So people can start to log in. We've got our back, we've got controls, we've got separate groups for departments, and then you can start to give them self-service to deploy infrastructure and avoid that VM sprawl problem that we're seeing when people are using GUIs with cloud services like Azure. So if I talk about some popular use cases, I think they come into these 6 areas. Provisioning is a no-brainer. So automating all the provisioning of all your cloud resources. This can also include bare metal and things under VMware. It's not just all about cloud, but Azure's put a lot of time into making it easy for you to leverage this tool and providing modules to be able to orchestrate every piece and every configuration. Configuration management's been around forever and it's still required. So being able to, configure all your environments and keeping them from drifting. Application deployment. So now we're starting to see people in the operations group hand down the power to the application teams to be able to manage their own applications. They can write their own playbooks. They can, control the life cycle of their application without everything having to go through an ordinance process and be handed from team to team. That really starts to enable the DevOps methodologies that we see, and people being able to control their applications and still fall into compliance and manage risk and security is a really good thing. So it drives innovation, helps your company move faster. Continuous delivery and pipeline automation is something that you always hear. There's a ton of tools out there. I mean, we use a ton of them, but you can certainly leverage Ansible and techniques to be able to do this. Security and compliance falls into all of this. So one of the biggest stories you'll hear from people that have adopted something like Ansible is when a 0-day comes out, it's really not a huge issue for them to run and patch all these servers. They've already done the automation work, so it's just second nature for them. They keep on patches. They don't have to do them every 3 months. It's a constant cycle. Obviously, testing becomes important, but that gets automated as well. So it's not easy, but you got to start somewhere. And the goal of security and compliance has a much bigger footprint than we've ever had. It's critical to be doing nowadays, especially with all these internet-facing applications. Orchestration, I mentioned we have workflow inside of Tower. You can build complete workflow playbooks that be able to do many different tasks and make decisions based on results. So you'll get to see a little bit about that later in the webinar. And obviously we want to automate all the things in Azure. It's a cloud. It's got a great API in front of it. If we can put time into automating these things, we're going to avoid a lot of future problems that we've seen get created in the data center. So I mentioned modules pretty quickly. So modules are used to control resources. Every aspect of Azure nowadays, you can see on the right, I've got a link to a bunch of the modules that are published and kept up to date. And again, we'll post this in the blog so you can copy and paste this out and go have a deeper look. But everything you want to interact with Azure services, including like identity and setting up load balancers, instance sizes, all the different services that they have, there's a module for it. So you don't have to go and code this stuff from scratch. You adopt these modules, you can leverage different variable techniques, and you can really hit the ground running thanks to the community and thanks to Microsoft and Red Hat for providing and putting the time into these modules. So start to look at these, start small, grab one, start to do some testing, I would say, with Ansible Core, and then you can move on to putting these things in Tower and putting some more governance around it. And if you want to hand self-service out to some team members, that's a perfectly great way to do it. So Ansible's rise in popularity, I look back, I've been doing configuration management previous careers, and we didn't have tools like this. And what really made it great, and if we look back to the days when we had Puppet and Chef and SaltStack and Ansible came around, I think one of the early reasons I heard people adopting it was really known for great Windows support in the early days. So everyone had Linux environments and it was fine. We had to deal with those, but we always took an automation approach to those. But Windows environments were challenging, and Ansible put some time into that in the early days, and they still do, obviously. The community behind it was fantastic. I mentioned Galaxy and people sharing code through that, and people being able to join the community and hit the ground running was very powerful. One of the things I saw early was vendors get on board. So people like F5 started building modules and putting them out to their customers to help them automate their infrastructure, so people didn't have to do it themselves. And I think you look now, every vendor's on board. They're all providing Ansible modules. It seems to be the de facto that they're shipping to their customers. And there's a lot of people with skills in Ansible, obviously, back to my point around the challenge of hiring great people to do these DevOps jobs. You're going to find a lot of people with Ansible skills. Python was a huge language. It still is. People are coming out of school with skills in Python. So I think the popularity of the language certainly helped. And that made integrations easy. Again, people sharing and exposing APIs and different playbooks to be able to be shared made a big difference. The rise in version control, native integration and version control is a super powerful piece. It really forces us to treat everything like code and not create a lot of technical debt. And I really think Red Hat did a great job with the community investment, and they still do. They're putting a lot of resources into that, and they're really fostering that community. So if you haven't seen Ansible, I've created a little example here on the right-hand side. Something as simple as the top piece of code here. It's a hello world example. The nicest part about this is it's human readable. You can, you don't have to have a lot of programming experience to get started and understand what it's going to do. Easy to run. Everything's saved as a YML or a YAML file. And it's as simple as just running the playbook, and then you get your results right away. A lot of things that are written in Ansible are idempotent, meaning you can run them many times. If the result is already achieved, it will just skip that. So it's safe to be able to reapply configuration. You don't have to worry about things getting broken. Obviously, it takes some work and strategy when developing these modules to make sure they're following good practice, but stuff you're seeing from vendors, and especially Red Hat, you're seeing that they're putting that time in, and it's a good road to go down. So I'm going to hand stuff off to the rest of the team here, Aaron and Phil. They're going to dive into a little bit more of a technical deep dive. The message I want to leave you with is, everyone can code, especially if you're jumping into Ansible and starting to look at automation. You don't have to have a lot of development experience. This is an open source community. We're sharing lots of things. We've got lots of blog posts and examples on how to do stuff. So I'd say just get started. Find an easy use case. Get with a team member who knows a little bit about it and start to share that knowledge. Put everything in your GitHub repos and be able to share that across the organizations. And you're going to find great benefit. It'll take a little while to get started, but you're really going to be successful in the long run. And I encourage everyone to get started and join the community and start to share that knowledge. So I'll hand things over to Aaron and Phil, and they'll take the rest of the webinar from here. Obviously, we're going to post this after, and we'll post a few blogs, and feel free to reach out to us if you need any help along the way.
Hi, everyone. This is Aaron. I'm a consultant at Arctic. Kyle, thanks for the introduction. We're going to move on to the infrastructure as code and tower architecture part of the webinar. So we kept it simple. We put a tower in the cloud. Particularly, we're going to talk about how Tower can assist as a tool in cloud specifically, rather than specifically talking about how Tower is built into the cloud. We will touch on it, but not into too much detail, just to preface what we're getting into. So, Ansible Tower in Azure Cloud, in our case, consists of one VM, the Postgres database that is built within during the default build. This is standard disks in Azure, and then deployment was done with mainly Ansible and a little bit of Terraform. And the FQDN that Ansible does require for its build, we did plumb with outside tooling. Now, if you were to take our infrastructure code and build it in Azure Cloud, you'd get a resource group very similar to this one. Everything from the VNet security group all the way to the VM and the disks. A very simple build, again. So what is there to gain by putting Ansible Tower into the cloud? There is essentially the full feature set, so long as it's supported by Ansible Tower. You can scale Tower from the first control node to Tower instance groups for zones and other regions to have equal reach to the Tower node. You can have highly available or clustered Tower with an Azure load balancer instead of a handmade load balancer in front of it, or have the Azure database given a little more resilience through a managed Azure PostgreSQL server. The benefits are really quite obvious once you've started to work with the tooling. So now the infrastructure as code piece. We really like the concept of infrastructure as code at Arctic. We believe that it's the way forward with how people are going to build automation code for things that they need to build. And just to explain what we're talking about, those familiar with Ansible know that Ansible needs playbooks. Playbooks are code, and playbooks define what you will make with them. So they are in effect your infrastructure as code. If you were to take all of your infrastructure, define it in some way, shape, or form, it would be checked into a source code repository such as Git. Infrastructure as code, ladies and gentlemen. Now, what is infrastructure as code? There is no official definition for infrastructure as code, so we put one together that we think makes sense for most cases. Infrastructure as code is the process of provisioning and managing infrastructure through machine and human-readable language rather than physical hardware configuration or interactive configuration tools. Specifically, the part about interactive configuration tools is what we're avoiding. We're trying to make everything automated or automatable through non-interactive configuration. So we initiate a configuration once, and it makes all necessary changes. Now, there are some benefits for infrastructure as code, some more obvious than others. We prefer to automate rather than hand bomb. It's much more appealing to do one VM by hand as opposed to 50 VMs by hand. That's when we start to veer into the area of preferring to automate much more than manually building out large numbers of resources, especially in cloud. We prefer less clicking and more code ahead of time and just use one shot of the enter key. so to speak. We also prefer to go with the fully defined environment method of building infrastructure code, rather than making small scripted chunks that have to be sequentially run once against one after the other in sequence. A fully defined environment is far more beneficial and gives you an anti-snowflake effect. Much of the benefit that all other code gets from being inside a Git repository, you gain with infrastructure code. Things like workflows and pipelines are these gains, and they're highly beneficial to do things like syntax checking or other similar tasks against code that lives inside a Git repository. Any developers on the call or people with a development background would know what we're talking about. Essentially, infrastructure as code is the open source collaborative method of bringing coding to operations people who previously only thought that developers needed to know this code. Now it's much more of a reducing of silos in order to bring a DevOps mantra to people who previously didn't use infrastructure code. With infrastructure as code, the code is your state, so it can be used for tracking and audit purposes, which has been a more popular reason to proceed with infrastructure as code practices in the enterprise. Now, why use infrastructure as code? There are some obvious ones, and if you have questions about some of them, you can ask us later, but the one we really like to get to is modular distributed code. This is the code that defines an environment that can be changed ever so slightly, and you would happen to be building instead of dev production. What we're getting at here is that the same code you use for all the environments should essentially be modular or variabilized just enough so that it can be reused and repurposed in other places instead of being built purely for one task or function. Now, more of the considerations for infrastructure as code: you gain access and RBAC by putting code into a repository that you can lock against certain groups of people in an enterprise, giving you a security layer. If those people can't access the code or the tools to execute the code, you have secured the infrastructure that the code would build. We like to advise that people go full automated, so to speak, in that they build anti-snowflakes. This is the practice of building not just the VMs and stopping there, but building all the VMs, the networking, and the application, all the way to application deployment in something like a cloud, so that there's no room for human error in the middle of making something build in an infrastructure as a service. Now, we also like to say that the tools are not competitive, but more complementary, in that people should use what works for them, but the reality as well is that something like Ansible is not competing with Terraform, and Salt does not compete with Puppet, for example, but the tools can complement each other if they're used properly. Terraform's forte is in infrastructure, spawning instances and resources, whereas Ansible is very good at the aftermath and configuration management. But at the same time, you could use Ansible to build out infrastructure, which is what we did for this particular lab. Now, some platforms lend better than others to infrastructure as code practices, but most with an API are plenty capable. Infra as code is an ongoing effort. You should not build it once and never touch it again. It's an ongoing task that should be constantly reiterated and improved upon. Otherwise, it will become dormant and forgotten about and under-documented when it's most important to be documented. Lastly, but definitely not least, is if you're going to proceed with having infra as code in your organization, you need to have a Git repository of some kind for all of this infra code. You'll be branching to track changes, and all of the code that is in progress of being built is the code that you don't want affecting your functional environment, and that is why Git allows you to do things like branching and forking. It's intrinsic to have a Git repo work with your infrastructure code, especially when you need to use it against perhaps multiple clouds or even multiple environments. Automation lends itself to efficient cloud use. If you're going to use infrastructure as a service, as long as it's automation friendly, whereas again, it's API reachable, infrastructure as code definitely is part of the IaaS story. Finally, the infrastructure as code as a concept or process. This is something to do when your organization or you as a person are ready for it. Definitely worth learning. However, it involves enough knowledge about what to do and what not to do when you're building in the cloud. Some of these things might be to understand immutability and what is the difference between immutable and non-immutable builds. And others might include using idempotent infrastructure as code practice. You want to make sure that your code only changes something when necessary and doesn't change things when not necessary. So that concludes my part of the webinar. Now we're going to move on to provisioning in Azure with Ansible Tower and your host, Phil Thompson.
Great, thanks Aaron. My name is Phil Thompson, also a consultant at Arctic, and I get to work on all sorts of fun Azure and Ansible projects. So I'm going to just go through a quick run through of the Ansible Tower interface, go through some of the playbook code we've set up, and give a bit of a demo of running that code in Tower to provision some Azure objects. So demo time. So we'll jump out of here and we'll jump into our Tower interface. So we've got our dashboard here, which is just going to give a quick overview of some of the jobs that have run, if they failed and succeeded. And running through the interface here, let's have a look at the projects. So the project is going to define where your playbook code is. In this case, we've got it set up to a GitHub repo. We've got it set to the master branch. We've got some credentials to log into GitHub, so it can pull down those playbooks. So if we go look at that repository, you can see in this playbooks folder, we've got an inventory file. So this is defining our VMs into some groups. It's going to use those groups to set up resource groups in Azure and the name to set up a VM. If we have a look at Azure, we can see there's some resource groups there, those groups that are matching the inventory file. And inside there's some VMs. So this code is the playbook's been run against that inventory file, and it's created some resource groups and some VMs. So we've got set up an Ansible role. We can see this YAML file is just calling out to run that role. If we jump into the role and have a look at the tasks, we can see there's creating infrastructure, which is going to go ahead and create the resource group and the virtual network, some networking available for our VMs. We've got to create VM. That's going to go and create that VM based on those resource groups and some of the networking info. And we've got some small playbooks here that are, destroy the VMs, shut down the VMs, start them. We've got this main playbook here, which is going to run when the Ansible role gets called out to, depending on what the activity variable is set to, is what the playbook's going to run. So we've just set up a kind of small code example. You can see it's nothing too intense or crazy. It's just going to kind of give you some food for thought about how to use Ansible and Ansible Tower to create some infrastructure in Azure. So it'll give you a good base, then you can kind of work off there, maybe use this in your organization to expand things, and then elaborate on those playbooks to create them more complicated and do some more advanced things. So it's a quick rundown of the playbook we've got. And if we come back into our Tower interface, you can see we've got this inventory section, so we need to define some inventory to run our playbooks against. So in this case, we've created an inventory file and we've set the source to that project. So it's going to actually look at that inventory file in the Git repo. We've also got some credentials. So we've got a credential so we can talk to GitHub. We've also got a credential for Azure, so the playbooks can talk to Azure and manage, create VMs and Azure objects. In this case, it's a service principal in Azure AD that we've put the details in here. And there's obviously tons of different type of authentication sources you can provide to Tower so your playbooks can run. If you have a look at organizations, users, and teams, one of the great things about Tower is the fine-grained control around permissions and groups. So the idea there is, you probably want to create some teams like the dev team like we've got here. You maybe want like a QA team as well. Two separate teams doing separate things. So the dev team's probably got some playbooks to deploy the infrastructure, maybe deploy their code. The QA team's maybe got some playbooks they run to do some tests and some queries and get some stats back. We can set up some permissions to say, when a dev user logs in, they're just seeing these sorts of playbooks and they can only run certain playbooks. And then when the QA sort of logs in, they're going to log into the same tower instance, but they're going to see only their playbooks that are applicable for their jobs. And you can get really fine-grained. If they just want to view the output of a playbook, they can do that. If they're allowed to run the playbook, they can do that as well. So definitely, that's one of the good things about Tower is that access control. If we have a look at templates, so these are the actual playbooks, the job templates that we run from Tower, and we've got two, kind of a workflow template and a job template. If you have a look at that job template, so this is what you give it a name, you tell what it's going to run, you tell it that inventory that you're going to run against, you tell the projects it's going to use, and then inside that project, the playbook. And then we also want to tell it what credentials we're going to use, which is those Azure credentials that we've set up with a service principal. And then if we want to provide some extra variables, in this case we're setting that activity variable to create infra, we're just going to call it to that task. So we define those job templates, and then we can run those job templates, and then that runs your playbook and it runs the jobs. The other type is a workflow template, where we can kind of group multiple job types together, just kind of like a workflow, which is pretty powerful. If we open up the workflow visualizer, you can see we've got sort of multiple steps in here. In this case, we're going to sync down that project. So the first step is going to reach out to GitHub and pull down the latest code. The next step, it's going to synchronize the inventory in that code. And then it's going to create the infrastructure. So it's going to call it to that activity variable, set it to create the infra, which is going to tell it to create the resource groups in Azure and the networking info. Once that's completed, it's going to create the VMs. So it'll create the VMs in there. And you have the option here to tell it when to run, if you want it just to always run all the time, or on success or failure, which can be powerful. If you're deploying a VM, maybe on success you want to deploy your code, but if it fails, maybe you want to run some sort of rollback or cleanup job when it fails. So you've got the option there to kind of build a pretty powerful workflow inside of Tower. So we'll close out of here. And so what we'll maybe go through here is we've got this template, this workflow template, deploy lab, which is including those, deploy the infra and deploy the VMs that we just looked at. What we've got it set up to do is inside of this Git repo here, we've got a webhook. So we've got to trigger that if there's a commit to the branch to sort of trigger this call to an API pointing to Tower. And it's going to call it to this workflow job template. In this case, the ID is 15. It's going to launch it, so it's going to launch that deploy. So the scenario kind of that we're looking at here for the lab and the demo is that isolated lab environments. This is obviously super handy for devs. So if they need to spin up an environment, have some VMs to play with on their own, it's segregated, but they can do that, as well as also maybe if you were looking at doing a sort of teaching a course where you had students come in and you need some separated environment for them to create and go through the labs. You would use this to spin up, say, 10 different isolated environments with 20 different VMs, and then be able to kind of spin that down once you're done. So if we go, so again, back on the infrastructure as code, right? We want to use code to sort of drive our infrastructure. In this case, being a dev, I'm just going to say maybe I've got these lab environments deployed. They're in Azure, but I need to have another VM. So I don't need to actually log into Azure or call it to any ops or infra team to create that for me. I can kind of drive that from code and GitHub and Tower. So in this case, gotta typo there, but that's all right. So in this case, I'm going to do lab 3, sorry, VM2, it's inventory file. So I'm going to save this, and then go push this inventory file up to Git. Cool, so that's been pushed up. I can jump into GitHub here and just refresh that. Cool, so we can see the inventory file is updated 17 seconds ago. So that should have called out a webhook and a trigger to fire off a job in here. If we come and look at jobs, cool, so we can see that there's some jobs running here. So if we have like this deploy lab, that workflow, cool, so we can see that it's gone through and updated pull down the latest code from the repository, and then it's updated the inventory file, and now we're just running the playbook to create the infrastructure. So we can see OK has gone through a few times here because it's already created some of the infrastructure from what was previously deployed, but we can see we've added that extra VM there. So we can see the output. While that's running there too, one of the things you can set up is notifications. So when jobs complete successfully or when they fail, we want to be notified somehow outside of Tower. In this case, we've set up a Slack notification. So this is going to send out to Slack to say like, hey, my job's completed. Here's the details, and it'll give you a link that you can jump in and view the output of the Ansible job. Cool, which looks like that's just triggered. So we come in here. Cool, so we can see that job succeeded. Gives us a link. So if I was a dev, right, I would have updated my inventory file there, pushed it to Git. I don't necessarily need to be logged into Tower at the time, but I would have saw that from Slack that, it's created the infrastructure, which is great. I can see it's created that my one VM here. I can see, if I click here, you can see the public IP it's giving me, so that's going to let me SSH in there. And if we jump back to jobs, you can still see it's running that deploy lab, and it's just deploying the VM now. Cool, so we can see it's created that network card for the extra VM and just go through and creating it. If we jump back here to Azure, you can see it's created that disk, and it looks like the VM's created. It's probably not fully created yet, and then we've got that extra network card in there. It's still running. So, and then what we'll do here is we'll just log out as a min user. We've got this Ansible Tower configured to talk to Azure AD. So obviously we've got the local admin user, but we want to set up a sort of a extra outside authentication source so we don't have local users. In this case, we've set it up to talk to Azure AD, but you can obviously connect that to Active Directory or whatever LDAP instance you've got. So we'll sign in with Azure AD, and we've got this dev user. That's fine, yeah, that was just trying to reload from where we were before. So we can see as the dev user, we don't have access to the administration settings here. We've just got access to the things that we want this dev user to see. If we have a look at job templates too, we can tell that we actually can't run these job templates. We've only got access to run this one manage Azure Lab template. We can see the output of here too, so we can see the output of jobs running. We can't modify anything, right? But we can see the completed jobs, so we can check the status. In this case, we can see that the job's run, so we can grab the IP address information. Have a look at, and we just got another notification. So the deploy lab succeeded. So I think that's just deployed the VM that we requested through the inventory file update, which is great. So it looks like that process is completed by updating the inventory file, pushing to Git, having Git trigger webhook to fire off Tower to build us a VM. now I've logged into Tower as my dev user, and maybe I want to manage some of the VMs in Azure, but don't have access to the interface. So I'm going to fire off this Manage Azure Lab job template. Here's that prompt we configured earlier, the survey. So the limit is, similar to Ansible commands. If you're running Ansible Playbook, you want to limit the playbook against a specific sort of host in the VM or group. So in this case, I want to say in Lab 1, we're going to limit to what I want to do. I just want to stop the VMs or shut down VMs. So we can see it's going to do a playbook run. It's going to use the Azure credential. It's going to use those Azure VMs inventory we configured there. The limit's just the lab 1, and the activity, that variable is going to set to shut down the VM. So yeah, so it looks like that's this job's firing. Tower's going to reach out and try and power off those ones we've set. So yeah, it's going to obviously maybe take a little bit to run with Azure to get that updated. But yeah, we've kind of give a quick rundown on Tower, kind of the interface, sort of the settings you need to go in there to configure to have it to work with Azure, and then gone through the kind of using the infrastructure as code principles, defining your inventory in code. In this case, an Ansible playbook file, and then cool. Actually, that just interrupted me there. Looks like we've got the that manager Azure jobs completed successfully. So I think that those VMs have been shut down, which we triggered from Tower. So the using the infrastructure as code philosophy and principles there to update your code, and then have webhooks and triggers firing off things to do in a Tower for you. So yeah, that was just a quick demo of Tower and Azure and Ansible. So there's obviously quite a bit there to take in. There's obviously a lot we wanted to cover. We couldn't cover everything. We had a kind of short period of time to do that demo. That's hopefully a quick summary. We'll be having this video uploaded into a blog entry, as well as we're making the kind of source code we used available on a GitHub, so you can kind of dig in deeper down the road on your own time. And just wrapping up some of the things we kind of learned in the webinar, we kind of went through, enabling your teams. You as an infrastructure ops guy, getting those playbooks written to manage objects in Azure and getting your teams onboarded into Tower. So they can leverage those playbooks and use them. It's going to enable your teams to do things smarter and quicker, not having to bug the ops guys to just deploy some VMs or stop and shut down some VMs. So you definitely want to get these teams onboarded and get them enabled. And get your code into GitHub or Git repo, just so you've got it documented in a playbook. You can see versions over time to see what's changing, what's getting updated. You want to lock down your master branch, enable the only thing that kind of gets updated to master branch is through pull requests. That way you've got some approval process of what gets added, what gets removed. And like everything, just start small and work your way up. Start with the just small Ansible playbooks, connecting to Azure, deploying objects, just creating resource groups, small things. Build those out bigger playbooks to kind of get them doing what you want, and then you can move those over to Tower for yourself, the ops teams, as well as designing things for different types of teams, your QA, your dev teams. And yeah, that's obviously you want to separate those teams in Tower based on their role. So there's probably a group of playbooks for a dev team. There's probably a group of playbooks for a QA team, for example. You want to separate those out to make sure that those certain teams can only see the playbooks they need to and run the playbooks they need to. And always leverage Ansible Galaxy where you can. So you can head over to the Ansible Galaxy website. There's tons of roles there. There's most likely a role has been created for something you need to do, so you can check that out. Pull down the role and reuse it if you need to, or even just pull out some code and some examples there. And just some resources, so always head over to docs.ansible.com. That's going to have all the detail about the Azure modules, what's required, some of the features there. This Microsoft link is pretty great. It's got some good sort of getting started with Azure and Ansible, some example code and some walkthroughs that'll help you get started pretty quick. Head on over to arctic.ca, where we've got a lot of blogs around Azure and Ansible Tower, so some good examples for things to do and activities on that end. And we've got the source code available, like I mentioned. We'll have the playbooks we used in the lab and demo environment And there'll also be some playbooks there that Aaron used to deploy Tower into Azure. So thanks, that wraps it up on the demo side.